Welcome. So this one is 3.2, task 2. It's called half interested. Interested in terms of money, likely. The scenario is a 5% annual interest. And from that 5% annual interest, you can calculate what it is after 5 years by multiplying by 1.05. In fact, that's what's happening each time because it's 1 plus the 0.5 interest that you're multiplying by. Okay, so each of these is a multiplication of 1.05. Carlos likes the idea of multiplying and getting a product like 402.02 and then taking that and multiplying that by 1.05 and then getting 422.12 and so on, and he repeats that process. Clarita uses an exponential function because if you're multiplying by the same factor, it's an exponential relationship. So in this case, our starting point is 382.88 cents. And we're going to multiply by 1.05 for however many years there are. So it's the years that is the variable here. And Carlos was surprised, but it worked out that way. So the reason is you have your starting point, 382 and 88, 88 cents. And first you multiply by 1.05. Then you get a product, and you multiply that by 1.05. And you get a product, and you multiply that by 1.05. You do that 5 times, right? And so, therefore, that's going to give us the same thing as if we use this function, but instead of x, we end up using to, let's say we want 5 years, we can say to the 5th power. Right, and that's how many times we're multiplying it. There's another one where you realize, oh, what if you go the other direction? You divide by 1.05 each time, dividing by 1.05. And therefore, we can look at where we were 1 year ago by dividing by 1.05, or 2 years ago by dividing by 1. And we could complete that table until we had figured out for 5 years, right? That's one way you could do it. Another way is the number of years could be negative. So we could do at our starting point, which is 382.88, and then we are going to still use the same exponential equation, 1.05, but instead of going forward, we would go back. So we'd say back -5. And the reason that works is because 1.05 to the -5th is equal to 1 over 1.05 to the 5th. So that therefore it's a division problem. The next one is about a situation where you're halfway through the year, okay, and you're trying to figure out how much money you got in interest. And Carlos, what Carlos did is he looked at all the interest. So from 382.88 was the starting point. Oops. 382.88. And then he looked at what was it after the first year, 402.02. And then he subtracted to get the interest. And then what he ended up doing is he said, well, what if I just took half that amount? Wouldn't that be the halfway point? The answer is no. This would only be the halfway point if it was a linear relationship with a constant rate. Okay, but we're not talking about a linear relationship. We're talking about an exponential relationship. So what we want to do is find the geometric mean, or the halfway point, and that's Clarita's strategy here, where the amount is equal to 382.88 times 1.05, but if we're halfway through, we're not an entire year, then we can take it to the half power. Okay, and that'll take us to the halfway. And then they ask you some questions about that. Another way is 3 months. We could use the same equation. It's 3/4 of a year. So if we start with 382.88 and we're multiplying it by 1.05, but it's to the 3/4 of a year, that would give us the amount after 3/4 of a year, right? And that amount is actually, oh, these are in years, so that's not right. The amount is actually 3/4. So if you found the 3/4 mark here, so it looks like that's about there, and there. You could find 3/4 on the actual curve. Now notice the dotted line is a linear straight line, but the exponential, what happens is it has the same starting amount, but it dips below that until you get at a point here. So it's at 4 years. I wonder if this is supposed to be in months. And then it's a curve, so it curves up and it exceeds the linear amount, but the linear is higher initially.